Haley will be on, but okay. So this course, we're going to have difficulty. We've basically lost 8 days, kind of, if you add it all up, because all last week, plus this week, and plus we were starting late as it was. So we got a boogie through it. So it's gonna move fast, but a lot of it we've covered. We've probably covered at least a third of this course already in applied. There's just some add-ons to what we do in applied. So you'll do all right. In applied, we spend all that time doing all those regression graphs and doing all the graphs on the calculator. In this class, we do nothing on the calculator, basically. We learn how to graph everything, pen and paper. And what you'll find is the first section begins that. We start by showing you how to graph without the use of a calculator. And you're going to find it tough. And then as we get into May and June, we're going to do it so often, you're going to say, oh man, I should have done way better on that first test because that was easy. All right, so that's the way it works. But I think the way we left off applied and where we start with this class, I think you're going to actually pick it up faster than what we've done before. Because I'm going to show you how we did it with sinusoidal graph, the last graph we did basically, right? And we'll pick it up right from there. Is because we now go back and we do all our exponential, our logarithmic, our polynomial graphs. We do them all exactly the same way now, using A, B, C, and D, okay, which is something we've done. So first thing I want you to do on the inside cover of your book, you're going to write this out. This is a refresher for you. Okay, so what I need to do, I'm going to show you 5 graphs right now. 5 graphs that you should know. 5 graphs that we use the base of all 5 of those graphs, and we translate them just based on the base of them. So like, for example, when we started with this, so you can start writing this down as I talk here. When we started with this with y equals x squared, yeah, on the front cover, just write that there's going to be 5 graphs I want you to put on your front cover just so you have them, so you can look back or whatever notebook you're using. Okay, so when we started with the y equals x squared graph, we learned 3 different ways to write it. We learned the general form, the rooted form, and then the vertex form. The vertex form is actually the form that is going to be the one that we use, the same method that we use for everything else, the A, B, C, and D. But I'm just putting these on here for you. And, whoops. Oh, my thing is off again. Okay. So it's important that we identify key points of all these 5 basic graphs as well, because we're going to use those graphs to move them. And I'll show you, the very first one I'll do is with the rooted graph, and I'll show you how we move it and how it makes sense to do it. So we need to know y equals x squared. We need to know what y equals x cubed looks like. We're going to put in a couple points that make the most amount of sense to us because we're going to move them. So I've got -1, -1, 0, 0, and 1, 1 for the y equals x cubed graph. Okay. The next graph is the y equals square root x graph. All right. Morning, Haley.
Morning.
All right, so what we're doing right now is just writing down 5 graphs that I need you to know. And just remember, we've worked with all 5 graphs, but we just writing down the key points of it. So if you want to write them down. Did you write down the y equals x squared graph by chance? Or did you just get on here?
No, I just got on here.
Okay, so the first graph I want you to write down is the y equals x squared graph. So just, do you have paper there somewhere?
Yeah, I just took a picture of both screens.
Oh, okay, that'll work for us. All right, so now I'm going to go, we got the rooted graph, and then we got the reciprocal graph. This is one we haven't looked at. We did polynomial graphs, but we didn't do the reciprocal graph yet, which is the 1 over x graph, right? Haley, you should be able to pretty much follow along all morning, even though you don't have the book yet.
I thought we did this graph
Okay, sounds good.
last.
Pardon me?
I thought we did this graph.
The reciprocal graph?
Yeah,
Um,
I think we did.
Yeah, we did. did we do a little bit of
Yeah,
that?
we did. A little bit, yeah.
Yeah, okay. Oh, yeah, with the asymptotes?
Yeah, was that last year? Was that this year?
No, it should have been, it would have been applied, I think. Yeah,
I think it's pretty tough last year.
maybe it was.
Yeah, it was pretty tough last year.
I don't remember. That's because I'm old, so. All right. And then the 5th graph is the absolute value graph. Okay. So we have y equals the absolute value of x. Oh, we did it in pre-calculus because we did piecewise a little bit last year. So, especially for this guy, we did that. All right, so those are 5 graphs. Now, you don't necessarily have to memorize them, but you're going to use them enough times that if you know what the base graph looks like, you should be able to translate it fairly simple from there. All right? We good? Okay, we have that down? All right, excellent. Okay, so now the rationale behind it. I'll come back to all that after. There we go. Okay, so the last thing that we didn't apply was the trig graph, right? So we did y equals a, don't write this down. We did this, right? So we did A, B, C, and D. Okay, and then what did A help us find? Amplitude. So, all right, now with the amplitude, okay, that's how much we stretched our graph, right? So our range changed because of it, correct? Our B, what did our B help us find? The period. So that affected our x values, didn't it? Because we divided 360 by b and we divided 2 pi by b, right, to get our period. So what you're going to find is we actually use that b and we divide all our x's by b, because that's what we did in the sine graph as well. Okay, what did c do to the graph? Phase shift. Very good. Okay, that means it moves it left or right. And then D, vertical, it was our midline, right? But when it's all said and done, that's a vertical shift. Okay, so all of this is what we are going to do in this whole first unit now. All we're going to do is work with A, B, C, and D, but we're going to do it in a different way than we did it with the sine graph, in that we're going to have a better understanding. And this may be where I should have gone. If we had a little more time, I could have gone with this approach for your applied, and it might have made more sense, because it's going to make a lot more sense today than what it did before. So here's what we're going to do now, okay? A normal, it doesn't matter what the function graph is. We are going to treat it exactly the same way all the time. So what I mean is this: a f of B, X minus C, add D. So of those 5 graphs I just showed you, I'm going to put them in this form where I have an A, B, C, and a D. And I'm going to treat every one of them the exact same way. All right? I'm going to do something with the A, I'm going to do something with the B, do something with the C, and do something with the D to move what we say is translate the graph. Now, like I told the girls yesterday, and Jose, we've gone through this with them, is that our focus will be on just C and D for the first lesson. But I want to show you the end game because this is what we have done already. So we're going to learn from what we did. So here's what we're going to do. I'm going to take a graph. I want to do the same graph here. So I've got, sorry, I want to find my graph. Oh, down here. Okay, 3, 2, 4, 1. 3, 2, 4, 1. All right, so here's what's going to happen. 3. All right, so now I want to be able to draw the square root graph, okay, without using graphing technology. So I want to be able to do something with it, all right? So in order to do that, I have to understand what's happening to each coordinate, okay? So now I'm going to go back. I'm going to go here now, and I'm going to rewrite this out. So I've got y equals a, f, b, x minus c, add d. All right. So here's what A, B, C, and D do to every single coordinate. Now I need you to write this down because this is probably the most important thing you're going to do, and it's going to be in every unit we do this year. All right, and that is this: what happens to my coordinate? Oops, I did this yesterday too. What happens to my coordinate because of all of these? So starting with A. So A adjusted my amplitude in the sine graph. Agreed? So what did I actually do to the coordinates to change my sine graph? What did I do? Yeah, but what am I changing? The X or the Y? The Y. Exactly. So what happens here is this. I got X and I go A times Y. So I took every Y coordinate on my sine graph and I multiplied it by A. And that's why it's stretched. All right? Because if you think about the coordinates, I had 0 and 0, and then I had 90 degrees and 1, let's say, right? Well, that became 3 if my amplitude was the 3. So I changed my Y values. All right? What about the B values? What did I change with the B values? What did B adjust?
The width from one maximum to the next.
Right, that changed my period, right? Okay, and how did it change it? What did I do to change it? Well, I took 360 and I divided by B, right? Or 2 pi divided by B. You agree? So what I'm actually doing is this. I take my X values and I divide them all by B. I still have a Y here. So what I'm showing you is how I adjust my coordinates for each of these graphs. C now. So what did C do to the graph? What did it change?
Phase.
My phase shift, which adjusted which values? My X, because I moved everything left or right. Agreed? So what happens here? I have X over B at C. Now, because it's subtracting the brackets, it was a positive c, so I had to move it to the right. So I added the value to my x value. Agreed? Okay. And what did my d value do to the graph? Change my y. That's right. So I have this, x over b, add c, ay, add d. All right. With that written down? Okay. Let's go back and let's talk about it a bit more. All right. Now we're not so focused on writing it down. Now we're going to discuss it. Okay. Look what happens here. I start with a coordinate xy. All right. The first thing I do is I work with a. And a is my stretching. So I take all my y values from my original graph and I times them all by a. That's how I stretch out my graph. Okay? My b value, I take all my original values, all my coordinates on my first graph, and I times them by 1 over b, or divide by b. So I take all my x values and I divide them by b. My c value, I take all the original x values. After I've made the adjustments here, I add c to them, so I move everything to the right. And then my d value, I have all these other adjustments made, and then I add d to all my y values. Okay? So what we did is we redrew the sine graph by putting down an axis, adjusting where my range was. First found my midline, right? So found my midline, did my period next, right? And then put in my axis after with my range. Okay, that's how we did the graph. Now I'm going to do it a little bit different. I'm going to take the 5 main coordinates of my sine graph. I'm not doing it today because that's the next unit. Take the 5 main coordinates, and now I'm going to make all these adjustments to those coordinates. Okay? All right, so let's go back to here now. Okay. The square root graph. Take a look on your page there. So I've got all right. What were the 3 key points for the square root graph? 0, 0, 1 and 1, 4 and 2. All right. So I'm going to do it on the next page here. So if I were to draw out my square root graph, it looks like this. There's 0 and 0, right? Here's 1 and 1. And here's 4 and 2. Pretty straightforward. Okay, so that's my graph. My next point would be 9 and 3. And then I might go 16 and 4, right? Or 25 and 5, because what it is I put in my value for x and I square root it. So I'm just using whole numbers to make my life simple. I have to do this without a calculator, so I leave it as whole numbers. So that's what that graph looks like, right? Okay, now you can do one of 2 things now. I can take my new graph with my A, B, C, and D, and I can draw it out on here and make all my movements, because that's okay. Or what I found last year, after teaching this for 20 years, I figured something out. It's far simpler if I take the 3 key points and I just focus on them and then redraw those 3 key points at the very end. All right? I wish I'd have known that 20 years ago. So here's what happens. Where am I? Right here. Okay. So I have my A value. What's my, the first thing I should do is write these out. A, B, C, and D. Okay? So in this equation right here, for my square root graph, what's my A value? For me? 3, B, 2, C, and D, 1. Everybody hesitated on C. Is it positive or is it negative? Right? So because this is subtract 4, it means it's a plus. If it was an add, it means you subtracted a negative value. Remember? So that's how come it's left and right. So we're good? All right. So A value times 3. So now what I got to do is I got to work with these coordinates now and do what I set on this board here. What do I do with the A? I times all my A values, or sorry, all my Y values by A. So let's do that. What does this point become when I times my Y value by 3? Still 0 and 0, right? This guy becomes what? 1 and 3. And this guy becomes 4 and 6. Perfect. Okay, write that down. Okay, what do I do with the B now? Say that again?
Divide the x by b.
Divide all these x values by b. So when I divide 0 by 2, what do I get? Good help. All right. That becomes 1/2 and 3. And this becomes 2 and 6. So I have now divided all my x values by 2. All right. Now let's work with C. What do I do with C now? All right. So what am I adding to each x?
4.
4 and 4.
Temperature here.
Actually, it was a little bit cool, but it's better now. Like these girls put their jackets on. So.
Never got to dress for the weather in school too.
Yeah, in
All right,
school.
all right,
Okay,
everybody
it
good.
is. Yeah. Okay, so what am I adding now? 4. So what is this? What's that first coordinate become then? 4 and 0. Perfect. Okay, down here, 4.5 and 3. Good. And here, 6 and 6. Perfect. Now D. All right, what am I doing with D now?
Adding 1.
Adding 1. So now what do I get?
4 and 1.
4 and 1. 4.5 and
4.
4. 6 and
7.
Is that wrong yesterday? I don't remember 6 and 7. Did I do that wrong? No, we had 6 and 7. Okay. And then 6 and 10. All right. So there's what I got right there, right? We're good? So now I'm going to graph those 3 coordinates. I'm not going to have them on the board, so you're going to help me. First coordinate is 4 and 1, right? Here's 4, here's 1. There's my first coordinate. What was my second coordinate? 4.5 and 4. Oh, now I made a mess of this. So it would be, redo. Let's do that. Lower. Okay. What is this? 4 and 1, right? Okay. So 1 and 1 is here. This is 4 and 2. Okay. Now I got 4.5 and 4, which I'm going to put right here. And then the last one is 6 and 7, which would be up here. Right? And there's my new graph. Okay. So now we got to learn the terminology and what I did here. Okay. So what did I do? I stretched it by a factor of 3. Good. I compressed it by a factor of 1/2 or 2. Like, so I can say 2. I can stretch it by a 1/2 or compress it by a factor of 2 because I divided everything by 2. I moved the graph 4 to the right and I moved the graph 1 up. That's how I went from here to that graph right there. All right. Now, what we just learned, we are going to use in every single unit that we do now. So all the graphs that we've looked at so far, the polynomial graphs, the logarithmic graphs, the exponential graphs, are all going to move the same, very same way. So I said you'll struggle, although I think the struggle will be a lot less this year because we have now seen this. I don't think I got to this until later in the year last year. And I think this helps a significant amount. Okay? So what I would have done before, all right? Remember what your A, B, C, and D is? Okay? So what I would have done before is I would have, so the A was 3, right? So I would have stretched this graph. I would have went 0 and 0, and I would have went to 1 and 3, and 4 and 6 up here. I would have put those on there. And then I would have compressed it to 4.5 and 1/2. So I would have moved this to here, and I would have moved this to here. All right. And then I would have shifted everything 4 to the right. So this would have gone over to here. This would have gone right to here, and this would have gone over to here, like that. And then I would have moved everything 1 up, got to here, here, and here. So that's what I would have done in the past. I would have done it all on that graph and moved everything. Now, it's far easier to take your 3 or 4 key points, or 5 if you're using trig, and just follow the process through for the 4 shifts. And that's it. Okay? We good? All right, now the one nice thing about this book, more so than any other, is it talks you through the steps and you can fill it in as you go. All right, so let's look at page 2. And I'm just going to go through filling in the blanks with you. All right, now actually there's one thing I didn't talk about today that I'm going to talk about right now, is if you look on page 2, it says for the graph f of x equals root absolute value of x. They want you to graph, and I don't like the way they wrote this, so I'm going to change it. Y plus 6 equals f of x minus 4. So when I first did this today, you'll notice I wrote it A, F, B, x minus c plus d all on the right side of the equations and left y by itself. I want to do that because my d value, the sign will be correct if it's on the right side of the equal sign. If the sign is on this side, it's opposite and it confuses you. So what I'm going to do is move this over. So I'm going to say, well, no, I want f of x minus 4 subtract 6. Okay? So do I have any adjustment of my a here? Because where is the a found generally? Before the f, so it's not in there. Any adjustment to the b? Any shifting with the b? Now, where do I find the b generally? Pardon me? After f in front of x. That's where my b is found. Okay. What about c here? What's my c value? Plus 4. And what's my d value? Negative 6. All right. Well, we just filled in the first blanks. Now, they're using h and k today. All right. Last year when we did parabolas, we used h and k. But I use c and d because that's what we use for trigonometry. And I want it consistent all the way through the course. So we're going to use c and d. So their h is our C, their K is our D. Knowing that H in this question is what? 4 means a horizontal translation of 4 units to the right. Okay? K is -6 means a vertical translation of 6 units down. Perfect. So you fill in your blanks. Okay? Now I'm going to do the first one with you. I got -5 and 5. So it even tells you what to do here. It says x add h, y add k. So if h is 4, what's -5 plus 4? -1. What's 5 add -6? -1. So your coordinate becomes -1, -1. 0, 0 becomes what? 4 and -6. Beautiful. 5 and 5 becomes
9 and -1.
9, -1. Awesome. That's it. Okay? That's how straightforward it is. All right? And again, we practice a little bit in the applied course. So I don't want to do too many of the examples, but I am going to do the next example with you because you need to go from one graph to another and describe the transformation. So f of x is the dotted line. Y minus k equals f of x minus h. Again, I don't like the way they write that, but whatever, is the solid line. So how do you go from the dotted line to the solid line? What transformations are made? So what you want to do is pick a coordinate and follow it to its point. So tell me, what do you do here? Somebody give me a coordinate off of the dotted line. 2 and what?
2
The dotted line.
2 and -1.
2, -1. All right. Which one is the same as 2, -1 on the new graph, on the solid line?
2 and 7.
Nope.
The same.
Look at the shape of it.
0 and 3.
0 and 3. I have two similar graphs there, right? So 2 and -1 is kind of that bottom right corner. So which one is the same on the other one, on the solid line graph? Yeah, that's what I mean. Okay? All right, so now, how do I go from 2 and -1 to 0 and 3?
Left 2 and up 4. Yeah.
Left 2, up 4. So what does that make h then? If you're going
-2.
-2. And what does that make k?
4.
Plus 4. So 2 is, -2 is h. K is plus 4. Write that down. Work backward from the graph to determine the parameters of h and k. So you've got x, subtract 2, and y, add 4. H is -2, k is plus 4. Okay, let's do the same thing in B. Use your vertex in B. How do you go from one vertex to the other? So remember, your dotted line is your first graph. Your solid line is your new graph.
Left 6, up 6.
You're going from the dotted line to the solid line. So what is it? Say that again. Right 6 down 7. So H is what? Plus 6. K is -7. All right. So we zip through it. All right. I want you to have a look at page 9. Again, I'm going to push our envelope a little bit to begin with, to try and catch up to our day's miss. So, our number, page 9, now deals with reflections. Okay. So what we're dealing with now, in the first section, we deal with C and D's. Phase shift, vertical shift. That's all you're going to deal with in 1.1. Okay? In 1.2, so girls, you haven't done this yet, right? In 1.2, we are dealing with A and B. But one very specific aspect of it, and that's when we have negative A's and negative B's. What happens to our graph? So let's use this as our way to explain it. Okay? So my first graph is f of x equals x squared. Okay? So that's the graph of y equals x squared. Agreed? All right. What happens when I put a negative in front of it? What happens to my graph? Yep. That's it. It's that simple, right? What did we learn in grade 10 or 11? Sorry. What happens when we put a negative in front of the x squared? Okay, what?
It goes down.
It will up. Okay. Now, we never talked about it in terms of what that meant in grade 11. So I'm going to talk about it right now. When you have a negative f of x, and again, the book makes it sound confusing, so I'm going to explain it in layman's terms so it makes sense to you. When you have a negative in front of the f of x, that's like saying, what does f of x represent in your equation? It represents your y, right? So if I'm putting a negative in front of my y, what's happening to all my y's? They become a negative. If they're a positive, they become negative, and vice versa. If they're a negative, they become positive, right? This is, write this down, a reflection over the x-axis. That's a reflection over the x-axis. So if the negative is in front of the f of x, we reflect it over the x-axis. Now, all that is a different terminology for you. You've done this. This is not new to you. We just haven't explained it in math terms. Today, we're going to explain it a little bit in math terms. Okay? So when the negative is in front of the f of x, that means that's a negative y. So you multiply all your y values. Now, when you are doing a in our equation here, all that would mean then is when I go through all my x and my y's, I'm just timesing them all by a negative whatever. Negative 2, negative 3, negative 1, whatever. So it doesn't change how I approach this at all. And that's the beauty of learning this as best we can immediately, is negatives won't affect you because the way you're going to do it, it's going to switch for you automatically. All right? Okay? Now, I'm going to use y equals x cubed now. So f of x equals x cubed. Oops. All right. What do you suppose happens here? Yes. So in math lingo, what would you say?
Goes from 4 to 4.
Okay, well that's well done. That's not the way I would have done it, but because you did learn end behavior, that's exactly correct. All right, but you guys are all bouncing on it. All right, but look what I said here. I can go back and think. Yes. Right? He's so smart. All right. It is a reflection over. Now, it's important that we learn that because in the book they say reflection in the, and I hate that. I don't know why, but I always say over and then I can't get it wrong. Over the y-axis. So what's changing? All my positive x's become negative, and all my negative x's become positive. And as Brooklyn said, which I really liked, was my end behavior is now 2 to 4. All right, because that's what we learned in applied. What happens when we put a negative? Our end behavior changes. Okay? And so this is, and if you look at this equation here, I think it's important that we see this. If I rewrote this equation, because I have a negative x, I put a negative in for that x, like this. And what's negative x cubed? Well, negative x times negative x times negative x, it just is negative x cubed without the brackets. Okay, so it's actually the same as what we did here. Okay, so looking at quickly on page 10. All right. It gives you a graph of y equals f of x, and it gives you a table of values. So let's talk about what happens here. Y equals f of negative x represents a so this is the part that we got to get right. Is this a vertical flip or a horizontal flip? Yeah, all right. Which am I changing? The easiest way to remember this is what values am I changing? My x's or my y's? X. And what is x? Horizontal. So it's a horizontal flip. Well, to some it would. All right? Because
That
this.
was horizontal. Horizontal this way. It's like flipping.
Oh, and it flips over the horizontal. Yes, it does. But if you're changing your x values, that's a horizontal flip. Okay? That's the easiest way to remember that. All right, so we're at a horizontal flip. Reflection of the function in the. This is why I don't like this. In the means the same as over. So which axis are we flipping over? Y. That's correct. If it's a horizontal, you're flipping over the y-axis. Okay? So x, y. So now with your coordinates, all right. So I've got x, y. Sorry, Haley, I'm going to try and help you here. I'll write this out from the book. So here's my coordinates. Somebody read me the coordinates. -6, 6, and then what? -2 and? -2, okay.
0,
0, -2.
3 and 1,
3 and 1.
5 and 0.
5 and 0. Thank you. All right. So those are my coordinates. Now, it said y equals f of negative x. So what that means is my xy becomes negative xy. All right? So now all I have to do is change all my x values signs. So -6, 6 becomes 6, 6. 2, -2. 0, -2. -3 and 1. -5 and 0. I'm only changing the x value because of the reflection I have there. Okay? We're all right? Okay, so one of the things that I was contemplating this morning as I lay in bed thinking about math, I'm a real winner, is when we have, like, in this book isn't as bad as the grade 11 book. The grade 11 book had lots and lots and lots of questions to do. This guy doesn't have a lot, but as you get into a rhythm, don't feel you need to do every single question here. All right? Once you do one, like, so for example, just do the odd ones or do the even ones. Today I would do most of them, because they're short, quick questions. 5 and 6, maybe you can do 5 or maybe you do 6, whichever. You don't have to do both. All right, but try and get through it. For Monday, this is asking a fair bit, but I would like you to get through all of 1-1 and probably to the end of, actually probably 1-1 and 1-2, if you can do that. Now, I don't like signing homework, but we are behind. So my attempt is to catch you up so that we get into a review. To me, this isn't brand new stuff to you, okay? And it's not overly taxing either. So there's 6 questions in that first book in 1-1, and there's 5 questions in 1-2. Okay? But if you feel like you've got them down, then you just move on. Just try and get to 1.2. I will go through 1.3 with you on Monday. Okay? Questions? We're good? All right, Haley, are you coming into town today?
I'm gonna see if my dad can drive me in at around 4. If not, I'll catch up during my spare on Monday.
Okay. Yeah, I was just wondering about getting you a workbook.
I can take one home with
Yeah, I can hopefully be in town.
Okay. Emma Boley's going to take one for you. Okay? So she'll have you can stay in touch with her and she'll have a book for you.
All right, thank you.
Okay? So, do you have any other questions here?
No, I'm good.
All right. We'll sign off then, and you should be good to go for Monday. Okay?
Okay, bye.
Okay. Talk to you later. See ya.